Hello everyone. Today I will be doing a question paper of EDEXCEL Pearson Mathematics Pure Mathematics paper. Okay, now please watch. I am starting it. Please you see. Okay, 1 second. Let me open the paper and then I am doing it. Please you watch. 1 second, let the paper open, then I am doing it. Please watch. Okay, this is the paper of Pearson EDEXCEL Level 3 GCE Mathematics paper. Okay, today we will be doing only 4 questions. Otherwise, the video will become very large. And the other questions of this paper I will be doing on the other days. So the question number 1 reads like this. The curve C has equation y is equals to 3x to the power of 4 minus 8x to the power of 3 minus 3. You are asked to find a part, find dy upon dx, and the second part of a, d squared y upon dx squared. Now B part, verify that C has a stationary point when x equals to 2. Number C part, determine the nature of this stationary point, giving a reason for your answer. Okay, I am starting it. So we are doing from A part. Okay, so here the equation given is equation of the curve C. The equation of C is given like this. So y value is equal to 3x to the power of 4. It is given 3x to the power of 4 minus, okay, 8x to the power of 3. 8x to the power of 3 and minus 3. Okay, that is the given equation of the curve C. Now, first A part I am doing. Okay, number A part, first part of A. We are asked to find dy by dx. Okay, so how we will do? You will here the power of x, you will bring it down. Okay, that will be multiplied with 3, which is the coefficient of 3x to the power of 4. Then you subtract the power of x by 1. So 4 minus 1 becomes 3. Minus, do the same thing with the 8x cube. So the power of x will move down. It will be multiplied with the coefficient of 8x to the power of 3. So 3 will come down and the power of x will reduce by 1. So 3 minus 1 becomes 2. And the constant differential coefficient is 0. So the ddx dy by, so ddx of 3 minus 3 will be 0. So no need of writing it. So now simplify it. This is the value of dy by dx. So 3 times 4 is 12. X to the power of 3 minus 8 times 3 is 24. X to the power of 2. So this is dy by dx. Now a second part I am doing. D squared y by dx squared. So now dy squared by dx squared. Now this number 1. So you will differentiate this equation number 1 on both the sides. You will get d squared y by dx squared. So differentiating with respect to x, okay, on both the sides of 1. On both sides of 1, we will get d squared y by dx squared. So this will become d squared y by dx squared. Now we will differentiate it. So bring the power of x down. So it will be multiplied with the coefficient of x cube. 12 will be multiplied with 3, and the power of x will reduce by 1. So 3 minus 1 becomes 2. Do the same thing with minus 24x squared. Bring the power of x down. Okay. So here you will multiply it with the coefficient of x squared. Okay. So the you write x and reduce the power of x squared by 1. So 2 minus 1 becomes 1. No need of writing 1. So it is just write x. Now simplify it. You will get the value of d squared y by dx squared. So 12 times 3 is 36 x squared minus 24 times 2 is 48 times x. So this is d squared y by dx squared. Okay, so this A part is completed. Now we are moving to the B part. So in the B part, it is asking verify that C has a stationary point when x value is 2. Stationary point means the turning points. Okay, so for the turning points, the value of dy by dx becomes 0. Okay, so here I am doing the B part. Now for stationary points, so for stationary points, what is the condition? The condition for the stationary point is dy by dx value becomes 0. So equate the dy by dx value to 0. So that is 12x cube. So therefore, the value of dy by dx 12x cube minus, okay, 24x squared. 24x squared. Equate it to 0. Now solve this equation and find out the values of x on solving. Those will be the turning points or stationary points. So we are solving this equation. Take the common from the left hand side of the equation. So 12 is common and x squared is common. Now divide both the terms by 12x squared and write it within the bracket. So 12 divided by 12 is 1. No need of writing 1. X cubed divided by x squared is x. Write x. Now minus 24x squared you divide with 12x squared. So minus divided by plus is minus. 24 divided by 12 is 2. And x squared we have already copied out. So it will be only 2. Will be equals to 0. So when the product of two expressions is 0, so either the first one will be 0, either 12x squared value will be 0 or x minus 2 value will be 0. So from the first, we are getting x squared value is 0 divided by 12, which is 0. So x squared value is 0. So x value will be also 0. And from the second, you solve, x value comes to 2. So the stationary points are, so the stationary points are here. X value is equals to 0 and x value is equals to 2. So at these points where the x point is x coordinate is 0 or x coordinate is 2, those are the stationary points. So we have showed it. We were asked to show that the C will have a stationary point when the x value is 2. So we have showed it that at the x value equals to 2, it is a stationary point. So it is proved. Now, second part, B part, we have showed it. Now we are moving to the C part. So C part says determine the nature of the stationary point, giving a reason for your answer. So there are two types of stationary points, the maxima and minima. So it is asking what type of this point, okay, stationary point is. Either is it maxima or minima? So we will check it. So remember it. For for I am writing here for explaining. Okay, remember this point. For maxima, for maxima, okay, for maxima, okay, the d squared y by dx squared value become less than 0 for that point, for whatever is the point of whatever is the x coordinate. You will put that x coordinate in the expression of d squared y by dx squared, and and if the value of d squared y by dx squared becomes less than 0, it is a point of maxima. And for minima, the value becomes, okay, the for minima, the d squared y by dx squared value becomes greater than 0 for that point, okay, for that stationary point. Okay, uh, which point I have to check? So here we have to check that is the x equals to 2 for that point where the x coordinate is 2. Is that point a maxima or minima? So for checking it, we will put this value of x equals to 2 in d squared, okay, y by dx squared. So putting x value 2 in d squared y by dx squared, or this state equation, or equation number 2, or in equation number 2. Okay, in the place of x, we will write the value of x as 2. So d squared y by dx squared is what? It is this 36x squared. It is 36x squared minus 48x. Okay. So in this expression, you will put the value of x equals to 2. So d squared y by dx squared, put the value of x equals to 2. We have to check what type of the stationary point is this. For checking it, we will put the value of x equals to 2 in this expression of the d squared y by dx squared. So in the place of x, I am putting the value of x 2. Okay, 36 times 2 squared minus 48 times 2. So what we get? Now simplify it. So this becomes 36 times 2 squared value is 4 minus 48 times 2 is 96. Solve it. So 4 times 6 is 24. Carry is 2. 4 times 3 is 12 and 2 add. So 1444 minus 96. So what we get? So d squared y by dx squared for the x value equals to 2. Now subtract here. 14 minus 6 is 8 and 13 minus 9 is 4, 48, which is greater than 0. So the result is x equals to 2 is the point of local minima. Point of local minima. Okay, I have explained you for the local minima, x d squared y by dx squared value is greater than 0. So here we are having the d squared y by dx squared. When we put the value of x2, we get the value of d squared y by dx squared 48, which is greater than 0. So x equals to 2 is the point of local minima. Okay, local minima. So that is the answer. So A part is completed. Now we are, oh sorry, question number 1 is completed. Now we are moving to the question number 2. So this is the figure given. Okay. Now see, I am reading it. This is the figure 1. So the shape ABCDOA is shown in the figure 1. Consists of the sector COD of a circle center O joined to a sector AOB of a different circle, also center O. So here it is saying there are two sectors. Sectors means a part of a circular region which is bounded by two radii. So when a circle, see here, this is a circle. A circle has a center point. So the part of the circle which is a part of the circular region between a radius, two radii, these are two radii, R and R. Between the two radii and an arc, this is a arc. Okay, so part of the circle between the two radii and one arc is called the sector of the circle. Okay, so here there are two different sectors of two different circles, and both the circles whose sectors are shown. Okay, these both sectors have the center O. That means the the O is the center of those two circles whose sectors are these, okay, which are shaded with blue and green color. Okay, O is the center of both the circles of the sectors of those circles whose sectors are shown. Okay, O is the center of both the circles. Okay, now given that the arc length CD is 3 centimeter, now here the length of this arc CD, that is the arc of the larger circle, okay, whose sector is the green part. The CD length is given here. Is here length is 3 centimeters. So the length of this arc CD is given in the question 3 centimeter. I am writing here. And the angle COD is equal to 0.4 radians. So the angle this COD is here 4 radians. Okay. Now radian is the circular, okay, unit of angle. Okay. And AOD is a straight line of length 12 centimeter. And this is a straight line AOD. That means the radii of both the circles are lying on a straight line. AOD is a straight line. Okay, and O is the center of both the circles whose sectors are shown. Okay, now we are asked to find the length of OD. So we are first asked to find the length of OD. OD is the radius of the larger circle. So this is the radius of the larger circle, and AO is the radius of the smaller circle. Okay, both are having the center O point. So we are asked to find the length of OD, that is the radius of the larger circle in A part. And in the B part, find the area of the shaded sector AOB. In the B part, we are asked to find the area of this shaded, okay, sector AOB, which is shaded in blue color. Okay, now I am doing it. Now you please follow here. So, okay, you should know this, okay, relation. So, if there is a one circle, okay, and its center is O, okay, now here is the center, and these are the two radii, okay, and the sector angle, this angle, suppose this arc is AB, okay, and the AB arc length is suppose S, and the radius is R, and the angle, central angle AOB is suppose theta radian. So there is a relation between the central angle, the radius of the circle, and the length of the arc. This is the relation. The central angle theta is equal to r divided by s. Okay, remember this point. Okay, 1 second. Okay, remember this. Okay, point. So then also I am checking it. 1 second. Okay, I am checking it. Okay, so this is what? Right. So S upon R. Sorry, it is S upon R, not R upon S. Sorry, it is S upon R. Okay, sorry. It is S upon R and not R upon S. Okay, I am writing here. So this is equal to R S upon R. Remember this point. Okay, S upon R. So the central angle value is the length of the arc divided by the radius. So we are asked to find the radius. So here radius is capital R. Okay. So what will be the value of capital R? It will be S divided by theta. Okay. So that is the length. This is the A part. Okay. So we are asked to find the radius. AOD is asked in the A part, which is the radius of the larger circle. So this R value will be, put the values. So S is here the length of the arc. Its value is CD, which is 3 centimeter. Okay, 3 centimeter is here. Okay, 3 centimeter. And the central angle value is 0.4 radian. Okay, you divide it and that will be the length of the arc. Okay, oh sorry, radius of the larger circle. So here 3 I am dividing with 0.4. The unit will be so many centimeters. So after 3 you put a decimal point and after the point you put a 0. Okay, shift the decimal point one place to the right on both the numerator and denominator. This becomes 30 divided by 4. So many centimeters. Now you divide 30 with 4. This become, okay, first you divide with 2. So 30 divided with 4 divided with 2, we get 2 at the bottom and 15 on the top. 15 divided by 2 is 7.5 centimeter. So the radius of the larger circle is 7.5. So that is the length of OD. So which was asked in the A part. So OD length is the radius of the larger circle, which is 7.5 centimeters. So that is the answer of A part. Okay. Now we are moving to the B part. Find the area of the sector AOB. So here it is asking, find the area of this blue sector, the sector which is shaded in blue color. Okay. So the area of the sector, remember the formula. Now B part I am doing. Area of the sector is, this is the formula. The central angle. Now this central angle I am denoting by, suppose this is the central angle of the this sector. Central angle is the angle which is made by the two radii. Suppose the central angle is theta. Okay. So it is the formula for the area of the sector is the central angle divided by 360 degree. This is I am writing in degree, the values of the angle multiplied with pi r squared. Okay, that is the formula for the area of the sector. Now you please follow here. Now here the sector angle is given. Now here this sector angle is 0.4. Okay, change this radian to degrees. Okay, we are changing the radian angle to degrees. Okay. Now we know that pi radians. Okay, pi radian, that means 22 divided by 7 radian. Value is 180 degree. This is the relation between radian and degree. So the given angle is zero point 0.4 radian. Change it to degrees. So this will be 180 unitary method. You will multiply it with zero point 0.4 and then you divide with 22 by 7. So 22 will be written at the bottom and 7 will be at the top. Now you find the value of so many degrees. So I am here using the calculator and changing this angle to degrees. Okay. So this value will be here 180. You will multiply it with zero point 0.4 and then further with 7 and then you divide that answer by 22. So approximately this comes to not exact figure, this comes to 22.91 degree when we round up it to the second place, because here it is wait, I am explaining you. Here the third digit, okay, the second digit after the 9 is actually 0. Okay, and the third digit is 9. So many degrees. When there is no ending digit in the decimal part, remember, always round up the number to the second place of decimal if there is no ending digit in the decimal part. So I am rounding up this angle to the second place of decimal. So in the third place it is 9. So when we round it to the second place, we will get it 9 1. So many degrees is the central angle in degrees. Okay. So this angle is here, this angle, okay, theta in zero point 0.4, which is here 22.91 degrees. When we change this angle to degrees, 22.91 degrees. So now because AOD is a straight line, so what will be the angle value AOB? From 180 you will subtract this angle, because when there is a one straight line, the two adjacent angles together value is 180 degree. It is called linear pair. So angle AOB value will be, okay, now because we are told in the question AO, here AO, okay, D is the straight line, because AOD is a straight line, okay, straight line we are told in the question. So the value of this angle, the central angle of the sector AO B, whose area we have to find out. So the angle AOB, this angle, okay, the central angle of the sector AOB, okay, that will be 180 minus angle COD. So angle AOB, so angle, central angle AOB value will be 180 degree minus the angle COD, whose value is 22 minus 0.91 degrees. So COD, it is, the reason is linear pair. We call it linear pair. Okay. Now you find out the value. So angle AOB value will be 180 minus 22.91, 22.91 degree. Now, okay, 91, sorry, 91 degree. Now, calculate its value. You do a rough work. Always remember, don't be shy to use the rough column. Okay, it is better to use a 1 minute than doing wrong. It is 9, okay, 0.9 minus 2 is 7, and 7 minus 2 is 5 and 1. So this comes to 157.0909 degrees. We may change it. Okay, okay, you may put it like this. Okay, So the area of the sector. So we are asked to find the area of sector. Okay, this. So area of this sector. Which sector? This sector. In the B part, we are told AOB. So the area of the sector AOB. Okay, AOB will be equals to AOB. Sorry, AOB will be the here this central angle 157.09 divided by 360 times pi r squared. So pi value is 22 by 7 r squared. R value you have to find out. That is the length of this AO. Now see how we get the value of AO, which is the radius of the sector AOB, a smaller circle. So here we have already found the length of OD, which is R. The R, okay, a value we have got 7.5. So this length R, small r, that is the radius of the sector AOB. What will be the value of small r? So from the total length AD, so total length AD is 12. From that length, you subtract the length of OD because AOD is a straight line. So from it OD length we have got 7.5. From 12 you subtract 7.5. That will be the radius of the smaller sector, which comes to 4.5 centimeter. So here you write, okay, this formula, okay, which I have told you. This is the area of the sector. Theta divided by 360. We are using here the unit in degrees, pi r squared. Okay, here r value we have got 4.5. So 4.5 times 4.5. So many centimeters squared because the unit is centimeter. So area will be centimeter squared. Okay, now you may calculate the value of this. I am using the calculator for finding out the value of this 157.09. You multiply it with 22. Then you multiply it with 4.5, again with 4.5. So that answer you divide with 360 first. Then you further divide it with 7. So the here the figure is coming 27.77 and 1. The third digit is 1 after the decimal point. So round up it to the second, okay, second place of decimal. So rounding up it is 27.7 because there is no last digit. Okay, so we will round up it to the second place. So many centimeters squared approximately. You will write here approx. It is not the accurate value, but it is approximately that. So that is how you will find out the area of the sector AOD. Oh, sorry. What is this? Okay, area of the sector. Okay, right. AOB. Sorry, area of the sector AOB. Now we are moving to the here question number third. So in this question, it says a circle C, there is a some circle which is denoted by the letter C. The equation of the circle is given x squared plus y squared minus 4x plus 10y value is equals to k, where k is some constant. Find the coordinate of the center of C. So first A part, you are asked to find the center of that circle whose equation is given. That circle is denoted by the capital letter C. You are asked to find the coordinate of the center of that circle in A part. In the B part, state the range of possible values of k. What is the possible value of k? You have to write the range for this k value. Okay, now see here. Okay, I am solving this question. So see here, remember one point. See, the general equation of the circle is this. General equation of the circle is this. Remember, this is the general equation of the circle. X squared plus y squared plus 2gx plus 2fy plus c, constant number, free from x and y, value is 0. So in this, okay, there is a formula for the center of the circle and the radius. So the center of circle is this formula. Okay, whatever is the coefficient of x, divide here the coefficient of x in this general form is 2g. Okay, divide that, okay, coefficient of x by 2 and write that as the x coordinate after changing the sign. So it is 2g. When we divide 2g by 2, we get g and plus g. Change its sign. It will be minus g. So the half of the coefficient of x with the opposite sign is the x coordinate of the center of the circle, and the and the y coordinate of the center, half the coefficient of y with the opposite sign. So here the half the coefficient of y is 2y divided by 2, which is f, and opposite sign, so it will be minus f. Okay, that is the circle center, and the radius formula is this. Remember, okay, this is whatever is the center, okay, coordinate, x coordinate, okay, square root of that, square the x coordinate of the center and square the y coordinate of the center and subtract the constant number c. That is the value of the radius. So the radius value is negative square or positive square is always positive. So this is g squared plus f squared minus c. That is the radius of the circle. Okay, remember these, okay, formulae. So in the A part, we are asked, find the coordinate of the center of C. So I am doing the A part. So center of circle C is what? See, I have told you, whatever is the coefficient of x here in this equation. Okay, so here I am changing the, okay, equation. Okay, I am taking the, okay, first we are writing the coefficient of, we are writing the coordinates of the center. So whatever is the x coordinate, divide that with 2 and change the sign. So the coefficient of x in this equation is minus 4. Divide it with 2. So, and change the sign. So minus 4 divided with 2, we get minus 2 and change the sign. So we will get the x coordinate as plus 2. So plus 2. And the y coordinate will be the half the coefficient of y. So here the coefficient of y is plus 10. Divide it with 2 and change the sign. So 10 divided with 2 is 5. And write it with the opposite sign. So it will be minus 5. So that is the coordinate of the center of the circle. That is the answer of A part. Now it is asked in the B part, okay, write the possible values of k. Write the possible values of k. So what will be the possible values of k? Now here we are changing this equation. Okay, bring this constant k onto the left side of the equation. So here the equation I am transforming. So equation of the circle C is here x squared plus y squared, okay, and minus 4x plus 10y. It is minus 4x, okay, plus 10y, and plus k was on the right side. Bring it to the left. Okay, minus k value is equals to 0. Let us check it. Okay, x squared plus y squared minus 4x plus 10y and minus k. Okay. Now here the radius become what? See here. So the radius value is here square root of g squared. I told you whatever is the x coordinate of the center. Here the x coordinate of the center is 2. Square it. Okay, and plus square the y coordinate of the center minus 5. Right, it square it. Okay, and the constant number you change the sign. Here the constant value is minus k. Change its sign. plus k. That is the radius. Okay, now simplify it. So 2 squared value is 4 and negative 5 whole squared comes to plus 25. Negative square value is positive plus k. Okay, now that is the radius of the circle. So here the radius I am writing simplify. 4 plus 25 is 29 plus k. Now see, remember it. For a real circle, the radius has to be always greater than 0. Cannot be equal to 0, otherwise it will be a point. Okay, point circle. But here we are told it is not a point circle. So this value of radius has to be greater than 0. Okay, so this value of so is greater than 0. So when the square root of 29 plus k value is greater than 0, so this value, okay, squaring both the sides, so this value become 29 plus k value will be also greater than 0. Okay, so the k value will be a real number greater than minus 29. Plus 29, I am moving to the right side of greater than sign. It will become minus 29. So that is the range. So what is the range of the value of k? So k is a element of real number such that k value is always greater than minus 29. So there are infinite number of values of k, all real numbers greater than minus 29 will be the values of k for this circle. So now we are moving to the last question of today's video. Otherwise, it will become a very large. Okay, I am doing the question number 4. Here the question number 4 says what? See, given that a is a positive constant, a is here the limits of this is a definite integral given. Okay, so the lower limit of this definite integral is a, and the upper limit of this definite integral is 2a. So this definite integral with the lower limit a and upper limit 2a, t plus 1 divided by t dt value is log 7, and a is here a positive constant. Okay, now show that we have to show that the value of a will be like this type of some number log of k, where k is a constant number which we have to find out. Okay, the a value will be like this type of number, so any number of this type log k, where k is a some constant number whose value is asked to find out in this question. So I am doing it. See here. Here we have to show a value will be a number like this form, log k form. So I am doing here definite integral. A is the lower limit, 2a is the upper limit. T plus 1 whole divided by t dt value is equals to log 7. Okay. Now you solve it definite integral. See how we solve it. Here you write the upper limit, lower limit a and the upper limit 2a, and divide here both the terms of the numerator by separately with the denominator. So the first term of the numerator is t. Divide it with the denominator t, and plus upper limit upper. Okay, the second term of the numerator is 1. Divide it with the denominator t dt. Okay, that is equals to here log 7. Okay, now you simplify it. So what we get here? So this is definite integral a to 2a. Okay, t divided by t value is 1, and 1 upon t dt. So that can be written as like this. A, you write these two, okay, integrals separately. So a to 2a, 1 dt. So that is only dt. Okay, integral of dt, right? 1 dt. So I am breaking this whole integral into two parts. So 1 times dt is dt, and plus 1 upon t dt. Okay, that is from the lower limit a to the upper limit 2a. So that becomes dt upon t value is equals to log 7. Okay, now you here write the integral of these. Okay, so the integral of dt is t. Okay, here you write here in box bracket lower limit a and upper limit 2a and plus. So integral of dt by t value is here log t, log of the denominator. So when the numerator is when integral is like that, the numerator of the integrand is the differential coefficient of the denominator. So the integration of that integral is the log of the denominator. So the integration of dt by t is log of t, and write the limits lower limit a, upper limit 2a value is here equal to log 7. Now you simplify it. So how we write it? So in the place of t, first you write the upper limit. So in place of t, first we will write the upper limit 2a, then subtract, and in place of t you write the lower limit a. That is the value of this integrand. So in the place of t, first you will write the upper limit, then minus. In place of t you will write the lower limit, plus. Do the same thing here. In place of t, first you write the upper limit 2a minus, then in the place of t you write the lower limit a value is equals to log 7. Okay, now you simplify here. 2a minus a value is a, and here you should know this formula of log. So if there is log a minus log b, so when we write these two logs together, it is like this. See, the from the you write log, and this will be a divided by b. So you will convert it to a single log like this, a divided by b. So this is, we are changing this log 2a minus log a to a single log. So this will be log, you will write log and 2a divided by a. Okay, that is equals to log 7. Okay, now you see here. Okay, now you please follow here. Here a and a gets cut out from top and bottom. So what we are left with? A plus, here we get log 2. Value is equals to log 7. Now take this log 2 onto the other side, because we have to find the value of a only. Okay. So I am taking the other term, log 2, to the left side, right side, sorry, of the equation. So that will be log 7 minus log 2. Okay, now use the same formula, log a minus log b. When we write it as a single log, this will become log a by b. Okay, I am now writing log 7 minus log 2 as a single log. So this a value is log 7 divided by 2. So the a value is like this, log 7 by 2. We have to show what was asked in the question. We have to show that the a value is something like this, log of some number. So we are getting that same thing. Okay, and here we are getting the same thing, that the a value is log of some number k by 2. So here we were told in the question a value is log k. So what, when you compare this equation with this, so in place of k, the value of k is 7 by 2. So therefore k value is 7 by 2, or in the decimal form you may write it as 3.5. So that is the value of k. Okay, so it is proved. Here it is proved, and the k value is 3.5. Okay, I hope you must have understood all these questions, and the remaining part of this paper, the other questions of this paper, we will be doing it in the other class. Okay, other video I will make it. Okay, I am ending the class. Okay, I hope you have understood the all the questions. Okay, thank you for watching. Okay, have a very nice day. Bye.